Hey everyone, here's some solutions for the Everything We Know About Parabolas assignment. This is just going to be the first question, the big chart from the beginning. You're given a parabola in vertex form, y equals -4 times x plus 1/2, that's squared, plus 1. And we need to convert it to standard form and to factored form, and then notice some other things about the parabola. So let's convert this to standard form. The first thing is we're going to do the squaring. So going to standard form is basically just simplifying everything. So to square this, let me just write out what this means. This whole thing is squared, so it's multiplied by itself, x plus 1/2 times x plus 1/2, and we leave this -4 out here for now, and this plus 1 at the end. I'm going to expand this binomial. Remember we practiced that? So here, I've got x times x is x squared. I'll just remind you how this works. We're going to multiply this by that, and also by this, and then these guys. So x squared, then this other one, x times 1/2 is 1/2 x, and then we have another 1/2 x right here, and then at the end, 1/2 times 1/2 is 1/4. And we have a plus 1 at the very end. Okay, and continuing, we have -4 times this stuff, but I can simplify in the middle here, right there. So this is still x squared. These two 1/2 x's become an x, 1x, and I still got that 1/4, and I have a plus 1 still. All right, now I'm ready to deal with this -4, so I'm going to multiply it by each of the things inside of this expression here, because this is the distributive property. -4 times x squared, -4 times x, I'm going to have a -4x. And then the last one, -4 times 1/4, that's going to be -1. And then I have a plus 1 at the end. Hey, look at that. These guys are both constant terms, and they happen to be sort of opposites from each other. So we have a -4x squared minus 4x. Okay, so that is standard form. All right, so now we need to get into factored form. There's really only one thing to do here. Maybe I'll change colors. To get to factored form, we're going to factor out what we can of this. First of all, I notice there's a -4 in each of these, so that's a pretty easy constant term to factor out. And I also see that I have an x in each term of this because there is no constant term left. So I'm going to factor out -4x. That leaves me with, here I've got -4 times x times x. I'm taking out the -4 and one of the x's. That leaves me with a single x left. Here I'm dividing out -4x, and this is -4x, so when I divide I'm left with just 1, and that's going to be positive, sort of the negative comes with it here. So that's the factored form. Write that here. Factored. There we go. That's pretty close to what that says. All right, now we have to decide, does this open up or down? Well, there's where we look. That is a negative number, so it's going to be opening this way, which we will call down. Okay, compression factor was 4. I gave that to you already. The vertex we need to read from the vertex form. That was what you had at the start. The vertex is going to be listed right here. The opposite value of this, so it's going to be -1/2 for the x. That is the value that x would be that would make this thing 0, -1/2. And the y value is going to be still +1. There's the vertex. And to see the roots I get right here. One of the roots comes from this side, so y equals 0 when x equals -1, the thing that will make this 0, or when x equals, well, what would make this 0? If x was 0, that would be 0. So those are the two roots for that equation. All right, so that's the first line, not exactly in order. We've got vertex form is at the top, then we found standard form, factored form, it opens down, and those are the roots. Okay, let's look at another one. The second one, I gave you y equals, in factored form, x minus 2 times x plus 3. Okay, so first off, I can read the roots right from here. The roots are going to be, based on these two numbers, the roots will be when when y equals 0, we're going to have x equals 2 or x equals negative 3. Those are the two roots. So those are the points, or you might also write x equals 2 or x equals negative 3. You can write that as well. Okay, so now let's get to standard form. So I'm going to take this, let me rewrite this. Binomial expansion again, multiplying x times x, x times 3, negative 2 times x, negative 2 times 3. So x times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, and then we have the two numbers multiplied together to give minus 6. It's collecting these terms in the middle that are the same degree, they're both degree 1, they have an x in them. X squared we leave alone. Here we have positive 3 minus 2 gives me a positive 1 times x, or positive x, and then minus 6. That's standard form. Okay, now let's get into vertex form. Well, we've got a couple ways to do this. One way is to use the roots, the other way is to complete the square. Let's complete the square with this one because it's not too hard. X squared plus x we leave alone, but now we're going to take the value here, which is 1, cut it in half, and square it. Half of 1 is a half. A half squared is a quarter. So plus a quarter minus a quarter. These cancel each other out, so we haven't changed the value of the expression at all. But it's a neat little trick, because then I'm going to have x plus a half squared is this thing right here. That's what you get when you square x plus a half. Now I have minus a quarter and minus 6. Well, minus 6 into quarters would be minus 24 quarters, so that's a total of minus 25 quarters. Now I have my vertex form. This has a compression factor, or a stretch factor, of 1. That's coming from right there. The vertex, we read from here, negative a half, and then this stays with the same sign, negative 25 quarters. And the roots we already did up at the top here, 2 and negative 3. So that's that one. All right, last question for this video. This is the hard one. I gave you this, 10 times x squared minus 93x plus 27. We're going to end up with some serious fractions here, and that's fine. Get used to it. That's the way real life numbers are. They pretty much never work out nicely. And these ones aren't too bad. They're pretty okay to work with. The first thing I'm going to do, this is standard form. So let's factor this. I'm going to use decomposition. There's more than one way to do the factoring, of course, but I like decomposition. It works well. So I'm looking for two numbers to replace this with, the 93x, and I want the two numbers that I write in the middle. They're going to add up to that middle number, negative 93. Make sure you watch that sign. And they're going to multiply together to give me 27 times 10, which is 270, and that's a positive number because these are both positive. I have two numbers that add up to a negative number, multiply to a positive number. They have to both be negative numbers. So let's try some things. 270 I know is 10 times 27. Because I want two negative numbers, I'm going to try negative 10 and negative 27. Those add up to negative 37, so that's not very good. Maybe I'll try doubling this one and halving this one. So negative 5 and negative 54. No, that's negative 59. And you could try a whole bunch of other ones. In the end, you're going to try something like maybe negative 30 times negative 9. No, that's negative 39. Let's try negative 90 and negative 3. Right, I took 3 from there and put it there. And that works out to negative 93. So I want negative 90 times x and negative 3 times x. I've separated negative 93, into two equal pieces. And now I can factor the first pair. Let's see, I can get a 10 out of both of them. Oh, and I'm sorry, I lost my x squared. I can get a 10 out of both of them, and I can get an x out of both of them. So 10x times, that leaves me with an x here, and a minus 9 there. And now, hey, I know I want an x right here, so I'm going to just factor out that minus 3. That's going to leave me with an x. And it'll leave me with 27 divided by negative 3 is negative 9. My little self-check here, these are the same, and they should be. Good. Now I'm going to factor that out, x minus 9, out of each of these giant terms. That leaves me with 10x and negative 3. Okay, cool. Hey, you know what? This is factored form, so I'm ready to look at this and see the zeros. So for the zeros, y equals 0, and so x minus 9 equals 0, or 10x minus 3 equals 0. All right, so solving this, that's x equals 9, or this one I'll do a little slower, 10x. So adding 3 to both sides is going to give us 10x equals 3. The 3's will cancel. Dividing both sides by 10, x equals 3/10. So those are the two zeros, at 9, 0 and 3/10, 0. Okay, hey, we're doing pretty good, but you know what? We need that vertex and the vertex form. That's probably the hardest one out of all this. Two ways to get there. One way is to complete the square. I think that's harder though. I think the easier way is to remember that halfway between the two roots is the vertex. So the vertex x value is the average of these 2 points, which is 3/10 plus 9 all divided by 2. So a little fraction work here. 3/10 plus 9 as a number of tenths is 90/10. And the whole thing is divided by 2. That's 93/10 divided by 2 is the same as multiplying by 2 on the denominator. So that's 93/20. That's the x value for the vertex. To find the y value, how do I do that? I'm going to substitute this x value into my original equation. So it's 10 times 93/20 squared minus 93 times 93/20 plus 27. Wow, those are some pretty serious fractions we got going on there. It's all right, it's not that bad. 10 times, I'm going to write it like this, 93 squared over 400. And see where I put my brackets? This is just going to be a big thing. I'm going to grab my calculator in a second and do that one, but for now I know what the 400 is. Minus, hey wait here, I've got another 93 times 93. That's another 93 squared. This one is over 20. And then here I've got plus 27. Ooh, okay, so some fractions here. Let's check this one out though. Here's a 10 times a thing over 400. That 10 can cancel with a factor of 10 out of that 400, leaving me with 40. So I've got 93 squared over 40 minus 93 squared over 20 plus 27. Okay, you can churn through this with your calculator if you want to. You're going to get a nasty decimal as well. Or you can notice here, doing a little common stuff, to get a denominator of 40 for both of these, I can multiply the top by 2 and the bottom by 2. 2 times 93 squared over 40. And you know what? Let's get this last one with a common denominator of 40. That's going to be, let's see, 1,080 over 40. All right, this minus this is going to leave me with negative 93 squared over 40. Oh, I'm running out of space. Plus 1,080 over 40. All right, so now you can do that. Let me keep my equal sign there. Now you can grab a calculator or otherwise figure out what 93 squared is. Sorry to write this horizontally here. and it is negative 8,649, and then I'm going to add in that 1080 all over 40, and when you get that final, oh, I ran out of space. When you get that final number, then it's going to be y is equal to negative 7,569 over 40, which is a decimal as well. Let's get an exact decimal. 189.225. That one does work out. And that x value, which was 93 over, what was it, 20, is equal to 4.65. All right, so that's the vertex then. The vertex is 4.65 and 189.225, or you can write it as 93/20ths and then negative, I should have a negative there, 7,569 over 40. Okay, yeah, gross. Those are pretty nasty fractions to work with, but that's the way it is. You've got to learn how to work with fractions and use them well. And I guess the last thing is to write down the actual vertex form. Y equals, remember our compression factor here was 10, and it was positive 10, upward facing, and we're going to do x minus 93 over 20. That's all squared, and then we subtract the y portion of the vertex. There we go. That's that last one. That was pretty hard, and hopefully that is good for you now. Practice those fractions and make sure you understand how the vertex comes out of the vertex form. We got completing the square, doing roots, all that kind of stuff. It's good. Okay, another video coming with the next two questions. Thanks.